So growth rate and doubling time. The growth rate K and the doubling time T are related by the following. So we saw this quite a few times. Essentially that every time I was trying to solve what my doubling time was, I had a natural log of 2, and it was always equal to your interest rate times the time T. So we know this is true. We know if we just want that interest rate or population growth or anything like that, well, all I had to do is just divide by T if I knew what T was. So if I knew what my doubling time was, it's just going to be natural log of 2 over T. And if I need to figure out what my doubling time is, I take a natural log of 2 and then I divide by K, my rate of growth. So note the relationship between K and T does not depend on P sub naught. Because regardless, if we double P sub naught, we know that what we're going to be left with is a 2, and I have to take the natural log of both sides. So I just get stuck with that natural log of 2. So this is the pattern we kept seeing over and over again. So instead of actually writing out this whole long problem where I go, well, I got doubling P sub 0, and then I have P sub 0 e to the kt. If we divide both sides by PO, we're just left with 2 e to the kt. And if I do the natural log of both sides, I have natural log of 2 is equal to my kt. So like I said, we're just kind of skipping the steps, and we're just going to go from here. So for example, the population of Kenya is now doubling every 25.8 years. We want to know, what is the exponential growth rate? So this is where we get this kt equals natural log of 2. So we know that this population is doubling every 25.8. So this is going to be my t. So k times 25.8 equals natural log of 2. If I want to figure out what k is my growth rate, well, that's just going to be natural log of 2 divided by 25.8. And what we get here is the growth rate, exponential growth rate, is 0.0, let's say 269. So my growth rate, the population of Kenya every year is basically growing by 3.69%. Let me fix that. 2.69%. Okay, so for this problem, one of them you're asked for growth rate, and one you're asked for how long it takes to double. So wild type yeast strains have a growth rate of about 46.2% per hour. We want to know, what is the doubling time for wild type yeast? And then the next problem, the bacteria, Centrophobacteria fumoxidans, that was a mouthful, doubles in the laboratory every 140 hours. We want to know what the growth rate is every hour. Okay, so for A, we are told the growth rate. So right here, we're essentially told what K is. So we see that K as a decimal would be 0.462. So we have 0.462 times T equals natural log of T. And what we were looking for is a doubling time, so we are solving for T. So T is just natural log of 2 divided by 0.462. Just a minute, I gotta put that back in my calculator because I accidentally erased it. And what we're getting here is the doubling time. So this is hours, is about 1.5 hours. The wild type yeast doubles in size or population roughly every 1.5 hours. So for the bacteria, we got that it doubles in the laboratory every 140 hours. So we know if the doubling time T, what we need to figure out is the growth rate K. So this is going to give me 140 T equals natural log of 2, which means if I want my T is going to be natural log of 2 divided by 140. Oops, sorry, I want my K. Let me go back and fix that. I wrote down the wrong variable. We have T, we want K. This means K as a growth rate is going to be 0.00495. The growth rate is, we write this as a percent, 0.495% per hour. So this is a kind of a pretty slow growing bacteria. So our first one, yeast, is growing really, really fast. This one's growing really, really slow.